So we'll be finishing this section on the first exam for physiology, talking about muscles and how muscles work. We talked about energy, how the process of making energy, making all this ATP and all this is good, but muscles are actually what allows us to exercise. And our muscles use this energy, this ATP, to contract and to exercise, and which we'll find out. But the very first section is talking about the three types of muscle fibers. Types of muscle fibers. Types of muscle fibers. Now, there's three types of muscle fibers. There's slow twitch. There's slow twitch muscle fibers, fast twitch muscle fibers, and there's another twitch muscle fibers that we'll talk about. Now, these are also called type 1 and type 2, but slow twitch and fast twitch again, because everything seems to be slow and fast in this class. So slow twitch and fast twitch will go by. Now, what this is saying, this word, these slow twitch and fast twitch, the definition actually tells you what the muscle fiber does and the characteristics of the fibers. But to make this simple, there's many characteristics of muscle fibers, but instead of memorizing every characteristic, let's just memorize one fact about muscle fibers. Slow twitch muscle fibers have a lot of mitochondria. Fast twitch muscle fibers have a few mitochondria. Now, if you just memorize this one fact about muscle fibers, type 1, slow twitch, have a lot of mitochondria. Type 2, fast twitch, have a few mitochondria. Very simple exercise. Very, very simple to remember. Now, the reason why it's best to memorize this one fact is because everything builds on this fact. Now, let's go to slow twitch. Slow twitch fibers. Now, remember, these have a lot of mitochondria. Now, what are mitochondria? Mitochondria, like we went over, are the powerhouses of the cell. These guys make the ATP. So, if we have a lot of mitochondria, that means we can make a lot of ATP. And if we can make a lot of ATP, that means they're fatigue resistant. That's the word they use. So they don't tire out as fast, or they last a long time before they tire out because they make so much energy because they have a lot of mitochondria. So these are the muscles that are used in endurance events or activities that we do pretty much every single day that we don't want them to tire out. They want to be fatigue resistant. Now, some examples of this is your back muscles. So your back is a slow twitch muscle fiber. Back muscle. Now, I know this is not atomically correct, saying back muscle. Your legs are also slow twitch fibers. Now, you can think of these as this because you use your legs, hopefully, many times a day by walking. Now, if your legs obviously they do have fast twitch fibers, but if your legs were mainly fast twitch muscle fibers, they'll tire out very fast. You want your legs to be fatigue resistant. Also, your back. Your back is a huge ass muscle, and it pretty much, I'm going to say it carries your whole body, but it carries your core, it keeps your core straight. Your back's pretty damn important. So your back goes through a lot of stress. So your back is fatigue resistant. It's a slow twitch fiber. So pretty much huge muscles are slow twitch fibers because you use them all day. Now a fast twitch fiber, vice versa, fast twitch, we'll just compare. Remember, fast twitch have a few mitochondria. Now if we have a few mitochondria, that means we can make energy still with glycolysis and whatnot. That's what it relies on, glycolysis and ATP PCR system, because it doesn't rely on this Krebs cycle and the aerobic respiration because it doesn't have a lot of mitochondria. You need mitochondria to do aerobic respiration. If you don't have a lot of mitochondria, you can't do aerobic respiration. If you can't do aerobic respiration, you tire out very fast because you only have a short supply of energy. So these tire out very fast. The word they use is fatigable. They tire out very fast. Fast twitch fibers. Now, let's say your arms. Your arms have, or your biceps, your triceps, really your biceps, your triceps, your chest muscles, whatever. All that stuff is fast twitch muscle fibers. Fast twitch fibers are pretty small compared to slow twitch. Now, these are fatigable. A way to think about this is you walk on your legs. You walk with your legs. Your legs are slow twitch muscle fibers. They're fatigue resistant. They have a lot of mitochondria. And what happens if you're walking on your arms? Luckily, that's not the way we're born. We don't walk on our arms, but if you walk on your arms, since your arms are fast twitch muscle fibers, they have a few mitochondria. Since they have a few mitochondria, they're fatigued very fast. You can tell that if someone's has enough balance to do a handstand and walk on their hands, your hands tire out very fast. I mean, if you mastered your balance, you would fall because eventually your arms will tire out because they can't support your whole body like your legs can because they're fast twitch muscle fibers. So going the whole list. Again, slow twitch muscle fibers will abbreviate as ST. We have a lot of mitochondria. That's one of the characteristics. Since they have a lot of mitochondria, they're fatigue resistant. They are fatigue resistant. They are large, which we went over, such as the leg, the back, and whatnot. They're pretty large. But this is mostly it. Fast twitch muscle fibers. Fatigue resistant, blah, blah. Another thing about them that we didn't really go over is they have a lot of capillaries. We'll go over that on the second test, I believe, a lot more on the capillaries and the cardiovascular system. Capillaries bring blood flow to the muscle. More blood flow, we know, equals more oxygen. More oxygen aerobic respiration depends on oxygen. That's what's called aerobic respiration. We use oxygen the very last step to form ATP. If we're, you can start thinking about this. If you have a lot of mitochondria and you use a lot of aerobic respiration, you probably need a lot of oxygen. In order to get a lot of oxygen, you have a lot of capillaries. So a lot of capillary density. They use the word density, just means you have a lot of capillaries in the system. So a lot of capillary density. So they're rich in capillaries. So that's pretty much everything for slow twitch muscle fibers. So now for fast twitch muscle fibers, or type 2, which we'll say is FT, because that's also some way how it's abbreviated. These have a few mitochondria. Since they have a few mitochondria, that means they can't do aerobic respiration. If you can't do aerobic respiration, you tire out very fast. You're very powerful. Yes, you're very powerful. We talked about how glycolysis, the ATP-PCR system, is for explosive activities. It gives you energy very fast, but you tire out very fast. You can't maintain that intensity for a long period of time. So it's fatigable. If it's fatigable, if you have a few mitochondria, you don't have a lot of capillaries going to that muscle. It's pretty much the opposite of whatever. Talked about how it's small. Small muscles, such as the biceps, the triceps, small muscles, the shoulders, the deltoids. The deltoids are fast twitch muscle fibers. Essentially small muscles. So small muscles, they have the fast twitch. They don't really do, okay, so the fancy word for aerobic respiration is oxidation, oxidative activities. Whenever oxidation uses oxygen. Fast twitch muscle fibers don't have a lot of oxidation, whatever. They rely on glycolysis and ATP synthase. So they have a lot of glycolytic enzymes, which is another physiological word of saying it, glycolytic enzymes. Glycolytic enzymes just means that it has a lot of enzymes that do glycolysis. If you don't have a lot of mitochondria, you have to get your energy some way, so you rely on glycolysis. And you need a lot of glycolytic enzymes to do glycolysis. Okay, I guess I said it the wrong way. Fast twitch muscle fibers are big. Sorry, just looking over the study guide. Fast twitch muscle fibers are bigger. That's not right. I don't know. Look up the size. I think they're small, but for some reason my study guide is saying big. I don't know. Maybe I wrote it wrong, but that's fast twitch muscle fibers. Now, there's also let's see if I got all the details about these. Fast twitch muscle fibers, they rely on glycolysis, glycogen, which is a storage form of glucose. They don't rely on aerobic respiration. They rely on the ATP synthase, the immediate energy systems. They have low capillaries, low mitochondria, blah, blah, blah. Okay, so another thing is, okay, so now we'll go to this because this gets a little confusing. Slow twitch, which are ST, are also called type 1 muscle fibers. I don't like the type 1 and type 2. Fast twitch is also called type 2 muscle fibers. You might see it as 2A. Again, it's stupid, all these numbers they're using. There's also something called fast oxidative muscle fiber, which is called type 2X. This really, if you understand type 1 and type 2A, this is really an intermediate muscle fiber. It has a little bit more mitochondria, but also relies on glycolysis. It does a little bit of both. It's abbreviated as FOT, fast oxidative twitch fiber, whatever you want to call it, fast oxidative fiber. So it's an intermediate essentially. It has some oxidative properties, so it has a lot of mitochondria, just like slow twitch. So it can do some aerobic respiration and whatnot, but it's not completely like type 1. It's not a slow twitch fiber. It's a mixture of fast and slow twitch. So it has a mixture. It's fast oxidative. There's less capillary density. That mimics fast twitch. Yeah. And the thing about the reason why there's an intermediate muscle fiber, which is type 2X, is because with training, we're going to discover that you can't really change. You're born with a certain amount of type 1. You're born with a certain amount of type 2A or slow twitch and fast twitch. You can't really change that with training. Like if you were born with 80% slow twitch muscle fibers and you train your ass off, you're still going to have 80% slow twitch muscle fibers. You can't change that. Some people are born to be marathon runners and long distance runners. Some people are born to be sprinters. It's how your genetics are. I mean, obviously a lot can do with training and will and motivation and inspiration, but genetics do factor into a lot of slow twitch and fast twitch muscle fibers. Now, you're also born with type 2X. Type 2X can be molded with training to act like type 1 with long distance training or act like type 2. That's why people adapt to training. That's the point of training. So you train your type 2X muscle fibers to be like type 1 or be like type 2, depending on what type of training you're doing. Which we're going. You can probably guess what trains will use slow twitch, which training will use fast twitch. You know the characteristics of these, so you can probably guess what training. And it also says in the name, slow twitch, fast twitch. But okay, so this finishes the video on muscle fibers. So in the next video, well, actually, it also finishes the next question on how they change with training. They don't, except type 2X. So the next video essentially is going to be all on muscle contraction and how the muscle contracts and how the actual process works.